Okay, so supersaturated solutions means that they've gone beyond the maximum amount of solute that can dissolve in that solvent. Okay, now what we're talking about here is something that actually has that beyond maximum amount dissolved. Now, I just finished saying that we can't go above the maximum, and now I'm telling you that we can. Okay, but making a supersaturated solution is actually a little bit more complex. You actually have to adjust the temperature and change the amount that you have dissolved. Okay, so I'll give you an example. So let's say we had our, let's start over. Okay, so let's say we had, I won't use a tea, I'll use a water. Okay, so let's say we had 250 milliliters of water, and at 25 degrees Celsius, the maximum we can dissolve is 10 grams. Okay, so that's like the saturation. So saturated would be 10 grams. Okay, so now let's say that I change the temperature to 30 degrees Celsius. And for my specific solute, let's say the maximum at 30 degrees Celsius is now 12 grams. So 12 grams is now the saturation point at this temperature. So remember, temperature can change the saturation point. So how we can make a supersaturated solution is you would basically have to heat the water up to this temperature and dissolve the maximum at that temperature. And then what we would do is let this then cool down. Okay, so if you leave it undisturbed, okay, once you cool it down, let's say it cools down to 25 degrees, you can actually have a situation where you have 12 grams that's dissolved, even though the maximum is 10 grams. So because you've kind of played around with the temperature, we've manipulated the solution to have more than the maximum by heating it up, dissolving more, and cooling it down. Now this solution, once we have a supersaturated solution, is very unstable. You have to remember you have more in there than what is supposed to be dissolved. So what happens is, if there is any disturbance, so I mean, let's say a speck of dust goes inside, or the table that it's on, somebody puts something else on the table and this vibrates a little bit. As soon as there is some sort of disturbance, what happens is the extra amount that you almost forced to dissolve in there will crystallize out. So let's say we did this exact scenario. We heated up the water, we put 12 grams in, and then we let it cool down to 25 degrees. If there is any disturbance, what will happen is the 2 extra grams that were dissolved in at that other temperature will basically crystal out. So sometimes this is called a crystallization, or you might even see the term precipitate. Basically, it just means that the solid is formed because of that extra amount that you went over by can no longer be held within the solution. So supersaturated solutions really don't have a ton of purpose. There's nothing you can really do with it, simply because as soon as you touch it, it doesn't work anymore, right? It precipitates out or crystallizes out. So what would you'd be left behind with a saturated solution. So that should kind of make sense. If my 2 grams comes out of it, that means that I still have my 10 grams fully dissolved. Like, I'm left with a saturated solution at the end of the day. So really, why do we make supersaturated solutions? Really, it's just to prove, the ability that we have different solubility levels. So basically, it's kind of like a proof, like, oh, for sure we know the maximum is 10 grams because 2 grams was precipitated out. So basically, if you wanted to know how much was remaining there, you could essentially just filter this out and weigh how much crystallized out. That'll give you the data for knowing how much the maximum is. All right, so how do we know? Oh, sorry. Let's just recap. So saturated. So here we go. Let's a person is going to pick up grocery bags. So we have two hands, right? So we can pick up. So most humans can pick up, let's say, 2 bags comfortably. So obviously you can probably pick up more, but comfortably 1 bag in each hand. That would be our maximum, our saturated amount. If a person's only holding 1 bag, we have an unsaturated amount. So the person has the ability to hold 2, but they're only holding 1, so we are below the maximum, right? So we're using our proper terms here. It's unsaturated. And this poor woman over here on this side is holding beyond what the comfortable maximum is, supersaturated. So this person is above the max. They have 3 overflowing bags plus her purse, and stuff's already spilling out. So this is remember, supersaturated solutions are very unstable, and I would say this is a very unstable situation. Okay, so let's look at this. This is called a solubility curve. So remember how I was mentioning that every compound has a different solubility amount, and it can change with temperature. That's literally the purpose of a solubility curve. It's a graph that will show us the maximum amount of solute that we can put in water at a specific temperature. Okay, so I'm going to explain how this graph works. There's a whole bunch of different solubility graphs that you can come across, but they all work in the same way. So as soon as you learn how to read one of these tables or one of these graphs, you're able to interpret it for a whole bunch of other types of graphs. Okay, so we have along the x-axis is temperature. So notice we are going from 0 to 100 real quick, but I mean, sorry, that was a bad joke. But anyway, so the temperature is going from 0 to 100. And the reason why it's stopping at 100 is because the solubility we are discussing here is for water. So remember that water, as soon as it goes above 100 degrees, it's now a gas. So we're discussing, of course, liquid water here. So let's say you were looking at a curve that was for a different compound. It would be the temperature range that that compound is in liquid form. So water is in liquid between these 2 temperatures, which is why we have this here. If this was, I don't know, a different, like an alcohol or something. So let's say the temperature range could be from 10 degrees to 80 degrees. It just depends on when the solvent is in liquid form. Okay, but like I mentioned, majority of the time you're looking at water as the solvent, but just in case you come across a different solubility curve, I want you to understand why the temperature may be different. Okay, so here we're looking at, so x-axis temperature. The y-axis is solubility. Okay, so I want you to notice the unit of solubility. Grams of salt over 100 grams of water. Okay, so first of all, when we say the term salt, it's any ionic compound. So this graph is focusing on ionic compounds in water. So it's the how many grams of that ionic compound can dissolve in every 100 grams of water. Now, sometimes you're dealing with milliliters of water and not grams of water. Okay, but the conversion is easy. 1 gram of water is equal to 1 milliliter of water because the density is 1. So this, in other words, this solubility that's being graphed here on the y-axis, the point, is grams of solute. In this case, our solute is the ionic compound in every 100 milliliters of water. So 100 grams of water, 100 milliliters of water mean exactly the same thing. Okay? And then you're going to notice that there's a whole bunch of different curves on here. So sometimes they're different colors, but it doesn't matter. The color doesn't matter. It matters what the curve is representing. So each different line that is on this graph represents a different ionic compound. So for example, this yellow line is lead to nitrate. This orangey line is calcium chloride. This light blue line is sodium chloride. The dark blue is potassium chloride. remember I was mentioning, I've already said this before, I sound like probably a broken record. Every solute has a different solubility, and it will change as the temperature changes. Right? We talked about the sugar in the tea, but it's the same idea. It's just we're looking at different compounds here. All right, so let's take a look at how we can read this. So hopefully we understand the, I'll leave this on this side so we can refer to it. Okay, so let's focus on one compound for a minute. So that way we can discuss what some of the numbers mean. Okay, so I'm going to look at this potassium chlorate. Okay, so we're going to focus on KClO3 for a second. Oh my gosh, my 3 is not connecting. Okay, so let's say I wanted to know how much potassium chlorate was able to dissolve in 100 milliliters of water at 30 degrees Celsius. So what you would do is, first of all, you'd have to find which line is potassium chlorate. So we have this like brownish line. And you would have to see where the curve lines up at 30 degrees. So this is our point right here. By looking at the y-axis, that's going to tell you how much the maximum amount is that you can dissolve in 100 milliliters of water. So what that tells me is if I had 100 milliliters of water and the temperature of the water was 30 degrees, I could dissolve a maximum of 10 grams. So this point, this line is representing the saturation point. So I know the maximum at 30 degrees in 100 milliliters of water is 10 grams. So what does that mean? What if I had a scenario, the exact same thing, but I'm going to dissolve KClO3. I have 100 mils of water and it's 30 degrees Celsius. But I'm going to dissolve 7 grams into the 100 milliliters of water. By understanding the information on this curve, the 10 is the maximum. So by knowing that I'm below the maximum, I can say, oh, hey, I know I'm going to make an unsaturated solution because I'm below the 10 gram maximum. If I were to dissolve 10 grams in 100 mils of water, now I'm at the maximum. Okay, I have a saturated solution, right? So that means if you were to try to dissolve more than 10, it would not dissolve. So let's say now I'm going to dissolve 15 grams in 100 mils of water at 30 degrees. What that would look like is you would have 10 grams dissolved and 5 grams clumped at the bottom. Because remember, the maximum is 10 grams. If you try going above that, that excess amount is going to precipitate or be essentially crystals at the bottom of this liquid. So be careful. Supersaturated, a lot of students, this is the biggest mistake I see. They say, oh, 15 grams in 100, that's supersaturated. So it is, but unless you actually change the temperature and warm it up to dissolve that extra 5 grams first, it is not going to have a supersaturated solution. But let's say we warmed it up. Maybe I warmed it up to 70 degrees and I can dissolve more in, and then cooled it down to 30 degrees. Now I can have a supersaturated solution. But just straight up 30 degrees, dumping in 15 grams, only 10 of those grams will dissolve. We'll continue this in the next part.